spectacular. So now we have another thing to look forward to in the next few weeks besides the launch of the imminent game consoles. So now let me introduce to you the last keynote speaker for our summit. It's Mark Papermaster, the CTO and SVP of R&D in AMD. So Mark has had a very stellar career. He's spanned the spectrum of semiconductors. He worked on high-performance blade servers at IBM. He worked on the iPhone and the iPod in Apple. And he worked on networking silicon in Cisco. So from the small mobile to the large server to the networking device. So he's got a tremendous amount of exposure on the silicon side. So we're very fortunate to have him at AMD. He leads all our technology R&D teams. And he's been at AMD for about a couple of years. In the time that he's come to AMD, I think I see three changes in him. One, he's become a very ardent advocate of developers, and he absolutely wanted to be the person to close the summit out, and he will. Two, he's a passionate supporter of surround computing, and I think his talk, he'll address that. And three, he's just become more feisty. And so with that, I'd like to welcome the feisty CTO of the world's feistiest technology company.
Thanks, Manju, and good afternoon. Hopefully, you've all had a great week at APU13. How's it been? It's been good? It's fantastic seeing the energy. It's fantastic just seeing the interchange going on, the dialogue on heterogeneous computing, which, was really just absent just several years ago. I mean, when you think about the progression, when you look at just this week, and you look at what are the articles being written about what you talked about at APU13 this week, it tells a story. It tells a story about new devices. That's what we're focused about at AMD. How do we create the engines that accelerate this whole era of, with heterogeneous computing? And so, announcing Kaveri, announcing the APU for the server, which we think will, provide, significant cloud compute advantages. Talking about Java, Nandini Ramani, talking about the advances in Java 8 and Java 9 to really leverage heterogeneous computing in APUs. It's been an exciting week. And, when I think back to 18 months ago, I had the pleasure and honor of giving a keynote at Hot Chips. And, I talked about what Manju mentioned it. I called it surround computing. We called it that we were actually hitting an inflection point where it was going to be a whole change in how we interface with computing. And, we talked about some of those signs, the advent of this change. We talked about, just at that time 18 months ago with Connect, with Google Voice, with Siri, that there were starting to be those signs of surround computing, changing how we leverage technology to interface in such a more seamless way. But let's look at even the last year. Let's look at some of the advancements that have come out. I am thrilled. When you look at the AMD engines underneath these new consoles coming out, I can't imagine a better embodiment of surround computing. You just see some of these games on these engines. It's going to be incredible, incredible. When you look at virtual reality, you heard from Brennan earlier on Oculus. I played this last week. As I had the headset on, the Oculus gear on a beautiful display, and it's surround gaming. I mean, it's incredible. You are in the experience. You are surrounded 360 degrees. It's a completely different experience than what we've had here to date. And you look at the drive that we have to leverage this even in our day-to-day technology. You look at the AMD-enabled tablets. The AMD PCs are out there that have the voice recognition, have the gesture recognition, the beautiful displays that we're driving. The rise of the 4K displays is truly amazing. As the price goes down, and the quality is simply amazing. At CES in January, we showed a demo called Surround House, and it was a true 360-degree experience. And, it was powered by, our, off-the-shelf AMD technology. And I'll put a little teaser out there. So it had all of the, surround, audio, surround video capability. It's pretty exciting. Please come visit us at January 2014 CES. We've got a lot more to come here. So round two. And true audio I'll talk about in a little bit more detail in just a moment. Okay, well, how do we get there in this journey? Well, it does start with looking through Windows and the tablet devices, through the PCs, through, even big screen experiences that we have today. That's the start of it. And frankly, at every turn, we're making it a more beautiful experience, a more natural experience. So we're making, tremendous progress here. But I challenge you. I challenge you to think about, as a development community, as technology developers, what's next. And what's next is really thinking about it differently, right? Let's break out of those conventions and let's think about this instead of Windows, instead of a more direct interface onto a single display, right? Let's think about it as building doors, building portals into a different experience, because that's what surround computing is. It's about enabling a different experience, a different way that we interface with computing, visualization, and compute, right? It's really about bringing in this next era. And there are tremendous opportunities. And, really what I'd like to have you think about is creating a digital realm. You can do this as developers with the technology that is becoming available right now. You can create the digital realms. You can have those high-definition screens that can surround you, positional audio that creates that experience of a digital realm. I love this photo. It's just relaxing looking to it. He's holding a Corona with a lime in it. You just can't see it because he's facing forward. But this is the scene. This is what I'm looking for with the kind of capability, kind of technology that we're developing. And so what is that technology? Let's spend a few minutes talking about the enablement. Right? So it starts with the visual realism that we're going to get. You've got to have the engines to provide the kind of resolution, the kind of rendering, real time that creates that visual realism. You've got to have very high resolution displays. It's got to come hand in hand with it. The audio has to match. If you have all the visualization without the audio, it's not a surround experience. And lastly, you've got to make it easier. It's got to be more natural is how we're interfacing with computing. And you've got to be able to trust that your data, your personal data, your work data is secure. So it's all of those elements that as a technology and development community that we've got to provide. And that's how we go through that door and create the digital realm. So let's start with the first one. We talk about visualization and graphics. We're very excited in this area. This is really a bread and butter for AMD in terms of taking the strengths we have, the heritage we have, and creating beautiful graphics and being able to drive more pixels. I mean, frankly, we feel that the industry is now really moving to our strength. When you look at the kind of displays which are out there now, and the ability that we can create our rendering engines that we have with our Graphics Core Next technology and marry that with our display technology, driving these high-resolution displays, we can really show our strength. And what we want to do is make it easier. Make it easier with APIs. You just heard from Johan at DICE about Mantle. Look what that's going to do in terms of taking the kind of optimization of games. I mean, those effects, he just showed it in a couple of clips. It's pretty exciting. It's pretty exciting. And imagine as you make that easier to get that out over a broader range of devices so that you have an ultimate experience in your console, but you take it with you. You have it with you on your personal computing, your mobile devices. That's what's in store for us. And it's got to go beyond that. It's got to go into really leveraging the whole set of APIs. We spent a lot of time talking about heterogeneous system architecture at last year's conference, at this year's conference. Tremendous advancements in opening this up to C++ AMP, Java, as you heard from the earlier speaker. This is the key. Create the technology, make it easy to deploy. So, I wanted to show a couple of facts and figures. We're going to, use an example. Of course, I'm going to use my example of the R9 290X. This is an amazing set of technology. When you look at 5 teraflops on a single device, and to think that 5 years ago, AMD was the first to break the 1 teraflop barrier. 5 years ago, 1 teraflop, roughly a teraflop per year improvement, and here we are with 5 teraflops on a single device. And you've got to feed those engines, right? You've got to provide a very, very high memory bandwidth. I mean, you've got, the capability of 300 gigabyte per second feeding this engine. That's a 20x improvement in just over 10 years. 4 billion triangles per second capability with an R9 290X. It's phenomenal, the draw capability. And so, we forget the rate and pace is inexorable. And all, you just step back and you look at the facts and figures, and you realize the engine to create the digital realm, the engines to power surround computing are here today. So when I look at display technology, right, and you look at the pixels bandwidth we have, it's not just drawing the pixels. It's about really enabling more, range, more, beautiful range of gamut, and creating an overall experience. That's what we're focused on in every generation. Create the engine underneath it, powered by our graphics Core Next technology. Create the display technology to enable the next generation. With our technology, typically, we were out there first supporting 4K displays. There's labs working on the next generation of display technology, which are using our graphics, driving it with our graphics. So we're very focused and will remain focused on our graphics technology engines. Got to continue to drive the pixels. But I said earlier, with it is the audio. I mean, that's what brings it to life, is when you have that spatial audio capability. And, when you think about it, what happens today, just as we're speaking here in the audience, right, you have 360-degree range. If someone, dropped their notebook behind you, you turn around. Well, you want that. You want that in your compute experience. Imagine in gaming, you want to know if someone's coming up behind you. You're gonna take them out. Imagine but think about, beyond gaming. Think about what that does in terms of realism in all of your interface with visualization when you have that spatial audio capability. And so, that's what we're focused on. We want to remove the barriers you have like today with the PC level of audio, and we're going to bring it right into that capability. With Kaveri, that you heard Lisa talking about on Monday, we have added the built-in audio offload capability that gives you that spatialization, gives you that 3D audio capability. So we're very excited about being able to provide sound that is, in fact, realistic. It's realistic. And it has the physics of sound. What do I mean by that? I'll make an analogy to graphics. I mean, with graphics Core Next, and you look at a lot of the games coming out on our technology, a lot of the visual, the rendering coming out on our technology, you'll see the physics applied. You can actually see strands of hair moving in the rendering based on our Radeon technology. But the same holds true to audio. There's no reason not to apply the physics to audio. So with an offload engine that we have with True Audio, you can hear that reverb. So it's not only that spatial, that 3D spatial, location of sound, but you should be able to hear the reverb. You should be able to hear the multiple voices, just like you do on an environment like we're in here today. So it's a much fuller sound capability that we'll provide with our True Audio. And frankly, with heterogeneous system architecture, we've created a way to exploit it. Straightforward APIs to be able to exploit this capability. And when you look at True Audio, these from a developer standpoint, we want it to be a real straightforward acceleration engine like the GPU. And so that's what we've done. It's certainly beyond gaming. By leveraging this API, we expect you to get acoustic correction, just like you can do video enhancement, you can do acoustical enhancement, positioning and positioning adjustment that you can do. And in fact, even the potential of real-time language translation and enhanced voice recognition. So we're very excited about adding True Audio into our portfolio of IP. All right, I want to now talk about what I call the 4 elements of natural interface, natural and secure, because again, you've got to have both elements. And so the first I'll talk about is hear me, right? And in fact, even more important than hear me, it's understand me. Do you recognize what I'm trying to do? And so it is about being able to have things like wake on command. That's already there today. But understand, be able to actually issue in natural language a straightforward set of instructions, have it understood, it understand my voice, and be able to have a hear resolution, resolution that recognizes me and the environment I'm in. When I talk about see me, it is that high definition capability that you're going to be able to play yourself back on, but you want with that the gesture recognition, real time, but you want it fine grained. To be natural user interface, it's not coarse movement like we have today, it's natural movement. Right? You want to be able to see the fingers, you want to be able to see the fine grained movement, right? And you want to be able to have what today is enterprise class video conferencing. You should be able to have that in your devices that you buy off the shelf as a commodity. And that's what we're focused on providing. Know me. You're only going to do this if you trust. You trust that other people can't come in and get at your data. I mean, that's obviously a very hot topic now for everyone in the industry, and frankly, it's top of mind internationally. But when you think about some of the best security, it combines multiple elements of recognition. It's fingerprint recognition, but it's face recognition. It's retina recognition, and so Know Me can bring in the ability to do applications like recognizing your preferences and bringing up your environment right away, but it's also a very key element of security, along with Show Me, right? And that Show Me is really making sure that whatever we provide in terms of technology enablement, it's on the cloud as well as the client, right? You've got to have that synergy because that's going to be the true enablement of this natural user interface. And that's why we're incredibly focused on leveraging our technology, both in dense servers in the cloud, very synergistically with the client devices that you'll be interfacing with. So those are the 4 areas that we believe will actually enable the natural user interface. I want to talk for a moment. I'd be remiss if I don't talk about our IP, our intellectual property. For me, this is where I spend a huge amount of time because this is our engines. And at AMD, we pride ourselves and will continue to focus on leadership enablement. Leadership CPU technology. We've been many years of x86, and we were the first to bring a 64-bit to x86 in the market. But we announced last year that we're adding ARM, so we'll have both x86 and ARM in our CPU portfolio. Graphics. We talked about just the latest with our GCN implementation with R9. We'll continue those investments. We'll continue the investment in the enabling software platforms and the associated IP. This is the base of the pyramid that we intend to provide our development community with leadership generation after generation of our AMD products. So I'm going to change gears a little bit. John at the outset of the session said, I want to share a little bit of news on a roadmap, and I do, because we're incredibly excited with a new SoC, a new APU that we're going to be rolling out in 2014. We'll talk about it more at CES in January, but I wanted to just share with you some of the excitement we have in AMD about the Beema and Mullins SoCs. You look at all the IP I talked about with our graphics core next and with our CPU lineup and all the enablement that we do. What we want to do is bring this right down into an even lower power. Same performance, same capabilities that we have today. If you look at, in fact, much more performance per watt, actually a 2x performance per watt improvement, but the same kind of graphics core next capability and CPU capability that you have today in our power optimized APUs. So it's our focus to be able to bring that AMD APU value proposition right down into the tablet space in a highly optimized way, right? Still having the quad core, still having the graphics core next, but adding in this power optimization, support for Microsoft Instant Go, and of course, support for security with our AMD Trust Zone implementation. We're very excited about Mullins. Look for more at CES in January. It's going to be a very exciting product for us in 2014. So let me summarize a little bit, and you look about the range of interfaces we talked about, from Mullins optimized tablets right through R9 290X 4K multiple displays that we can be powering, with that realism, that eye definition realism that we talked about. That's what's in front of us. That's what I call, really the enablement of surround computing. The engines are there. The capability is there. You saw it this week. You saw it in, the rollout of each of the various demos that you saw today. You heard from Dominic on consoles earlier, right? So you're seeing that the technology is there now to bring this kind of capability. And, my commitment to you as a technology and as a developers team is, let's take the challenge on. Let's partner. Let's make surround computing a reality, and let's do it right now. Thanks very much. Appreciate your time.